All right, so I think we're the last team, so I'm going to try to be really, really quick. The premise of our work is that for some reasons that people who like to be called evolutionary psychologists would be eager to explain to you people have friends. And we decided to run an anomaly detection on the friends check-ins into different places on Facebook. So we got the data from Facebook, which is a relatively difficult process considering they changed their API 4 days ago and nobody knows how it works. But basically, we, go ahead.
So basically asking for your permission.
Yeah, so now it's downloading and analyzing the data to figure out which of the latest friends check-ins are anomalous. The reason why we think that's interesting is that most of our friends kind of do the same things every day, so we don't necessarily want to talk to them about it. But if they do something interesting, something outside of their range, we'll likely to ask about it. The interesting part about this project is the encoders you...
Could you I have no idea what the data is you're actually looking at.
Yeah, so the data for a check-in is location of a place they checked in, with whom they checked in, how many people like the place, and categories. There's a lot of categorical data how Facebook categorizes different types of venues.
And you can get this for all your friends?
Yeah, well,
Wow.
if they allow.
Okay, all right, got it, thank you.
Some friend, which is the default. So as you can see, we tried to make the things that are very well, predictable kind of transparent. So you see that people who go to bars and sandwich shops kind of transparent, but whenever it's an event that doesn't really occur all that often, it's a bit more opaque. The interesting part about this is creating the encoder, because we're not predicting any scalar value, but rather the similarity between check-ins. So you can't do any swarming, you have to manually create the encoder, and we assigned half of the SDR to location, that's half of what we consider to be anomaly, and approximately a little bit more than half of the rest to categories, and the remainders to things like how popular is the place, how frequently do people check into it, and how many people have people checked in with.
How much data do you have? How many?
So these are the people who have the most data. On average, a little bit more than 100 check-ins per person.
For how many, what time period?
Throughout their history. So
throughout.
On Facebook, yeah.
So all my friends basically and all their check-ins and all his friends and all their check-ins. And then we analyze those and we surface the one that have the most data kind of, so we have a better image. Sorry.
So are you building a separate model for each friend? Is that the?
Yes.
Yes.
But you have 100 data points for each friend?
Yes.
So it's not a lot of training data?
Yeah, exactly. And so even the transparent ones, the anomaly scores are really high. They're like at 0.3, 0.4, but compared to the real anomalies, which are 0.8, 0.9. So the difference is noticeable.
You're saying it actually worked?
Yeah.
Oh, okay. I wasn't sure if this you're showing what the results you're going to show us, or this is actually the results.
Yeah.
Oh.
It's the opacity
Got it.
significant, like
So
who's
it's-
cool
okay.
and who's actually boring. So you could look at it as what kind of, sorry for all my friends, but anyway.
Well, I mean, I guess you'd have to know your friends and know whether this is unusual or not.
Yes, but I mean, we based it like on if they do something different than what they do usually, then it's something interesting. But like our concept, and furthermore, is really like, imagine you're actually going to your social media and you have all these people that saying, I'm brushing my teeth.
Yeah.
I don't want to see that.
I got it. I just don't know if Mama Bear goes to Microsoft a lot. I mean, you know, the Mama Bear conference?
That's the name of the event.
Oh, I see.
So since it's not transparent, that's unusual.
Yes.
This is transparent, so this is more...
I guess I have to trust you that that's the right score. I mean,
You have to kind of...
yeah. Yeah.
It's the name of the event where they check.
I got it. I got it. So I wouldn't know, you know, maybe the person checking in the Fifth Street Distillery is a Mormon, never drinks at all. That would be pretty unusual, you know.
Right.
Not for that person.
We find that detecting anomaly on like contexts that are news or text or like even is really interesting, because you could actually on the fly look at a news, for example, and know or like teach it while you're doing it, this is a content that I like, and since we have an SDR on that content, the page could be like filtered on the fly while I'm looking at New York Times, and it's actually showing me only the thing that interests me. So it's really the kind of the bigger vision. Sorry about that.
Cool. I thought it was a cool interface too.
Yeah.
Yeah, I was just thinking, while you were just saying that, it might be interesting to, if you took the text associated with the event or the place that the people had checked into,
We thought about it, we didn't have the time for it.
and combined that with the set, got a SEPT SDR for that,
So,
and then use that to further refine what how the thing worked.
yeah,
You know,
there's
in Grok, we have this. We take all these server metrics and server data, and we show them in order, ranked by how anomalous they are. But this is a really cool thing. You're using this sort of opacity to sort of make it pop out at you.
Right.
Much cooler than what we did.